Hello, hello! Today we get to talk tides on our Science Mondays with Stina, Science with Stina, here on a Monday, talking tides with you all out there. I'm going to give you a little bit of time to join in on our live stream today. We are indeed going to investigate tides with you, as well as what causes the tides and how you can plan for the best low tide beach walk. So as you get tuned in, we always love for you to mention in the comments where you're tuning in from and what students are tuning in with you. That definitely helps out with our grants during this interesting time of learning, and we hope that by the end of today you have a better grasp on how tides work around the globe, but especially here in Washington State, so that we can get out and play on the beach with you all. So while we go over tides, we'll go through the materials for making our tide-o-matic today. This will be our tide model, and you'll actually get to move the moon around the earth and between the sun and see how that water might change over time. So things that you will need: I have some paper. I'm reusing my English muffin wrapper, so whatever paper totally works. We can get creative during this time. I shout out to Millville Pizza for my lunch today, and my piece of cardboard that we're going to be using. So cardboard's handy. If you can get some packing tape, that also works well. I need 2 push pins. Pieces of cork. I just used a knife to slice off wine cork there. That is for safety later. A pair of scissors. I have a pencil, and then I have an assortment of markers, some coloring devices, including at least 1 Sharpie, because we are going to be drawing the moon on that packing tape. So I'll let you go ahead and get some of those materials as we talk about tides today. Before we build our tide-o-matic. This idea is indeed thanks to the Exploratorium, a fun little website I discovered in digging around trying to figure out the best way to explain tides to people. So what we're going to do is we're going to talk about the tides, as well as the phases of the moon, and then we're going to build our own tide-o-matic to model how those tides work. So first, the tides. If we were to pull up a tide chart today, you could pull it up really for anywhere around the world, but you would see that in Washington at least, we have 2 high tides and 2 low tides every single day. These are called mixed semi-diurnal tides, for those of you who want a mouthful of a word. And that essentially means that our tides are of differing heights throughout the day. So we have our highest high tide that then drops down to our lowest low tide, and then that will raise to another high tide, and then a low, and then that cycle repeats itself. And that's about a 24-hour and 50-minute cycle if I were to go from the high to the next high. So that thanks Harbor WildWatch, yeah, definitely. Thanks Carly out there running our tech. She'll add in the supplies that you'll need for our tide model later. So thanks again, Carly. So there's a reason that Harbor WildWatch can't just plan a beach walk every single day at the same time, and that's because the tides change. And the tides change because of the moon. And so on our next sheet, I have the moon phases kind of listed out here. And I don't know, can anybody in the comments share what has the moon been doing lately? What have you noticed? What phase is the moon in? It kind of alternates on about a 27-day cycle, some say 29. Somewhere in there is our lunar month. And it goes from a new moon, so if you look up in the sky and you don't see a moon at all, then well, it could still be rising or has already set. But if you don't see a moon, it's likely a new moon. And then as it increases in illumination, we call that waxing. So you'll see the little sliver to the half to getting bigger to full, and then that illumination starts decreasing, or the moon will start waning. You might hear waxing and waning. I like to think like wax on, the moon's getting bigger, and then waning, it's like getting smaller and smaller and smaller, so you barely see that little crescent, and then boom, we're back to a new moon phase, and then that cycle just keeps repeating. Now, of course, our moon is on an elliptical pattern, and so there are times where the moon is closer to the Earth than other times, and that will be important when we start talking about things like king tides. We'll kind of put a pin in that to come back to later. So glad to have Sherry joining. Welcome, welcome. Here we are with our lovely moon phases, and I definitely remember, I think I was in maybe 3rd grade, and I had an assignment for a month, every night we had to go and draw the moon from the window, and that's kind of, I don't know, I think a really formative thing to like have this cycle of the moon observed as a little kid, so you really kind of get to notice and appreciate like, okay, what the moon's doing, it's always doing something, and then we'll learn more about how that impacts the tides. So there's kind of our moon phase, and I will mention that this is for the northern hemisphere. If we were in the southern hemisphere, it'd be totally flipped, which is just kind of a cool, wild, unique thing, because based on the tilt of the Earth, you kind of get a different perspective of the sky depending on where you are at on the globe. So back to tides and how the moon impacts the tides. We, of course, are out doing this spinning space dance. The Earth spins around the sun, or rotates around the sun. Orbits, perhaps, is the best word. It takes 365 days to do that, unless you're on a leap year. And so as we're spinning around the sun, the Earth is also spinning. We take 24 hours to do a full rotation as we're spinning around the sun, which takes 365 days. And then while we're spinning, the moon is also orbiting around us. We love doing this, we call it the tide dance. We'll get, someone with a really down-to-earth personality to stand in the middle with our Earth model, and then we'll get someone who's a little loony to hold the moon, and then someone with just the bright, sunny personality, they're the sun. Hi Octavia, thanks for joining. And they'll stand out, and then everyone else, and they'll join hands and circle the Earth, and then we'll have the moon rotate around and demonstrate how the water is shifted depending on that gravitational pull, which we are going to talk about a little bit right now. So depending on where the moon is in its phase, right now I have it drawn in the full moon phase. That's the sun is shining and it's getting that full reflection, and that pull, it's actually, I just watched a video. It's technically not a pull. It's more of a gravitational push. And there's a reason that I guess there's tides everywhere. So there would be a tide in my cup of coffee and a tide in a lake, but they're imperceptible because it really takes that big, huge body of water like the ocean to have a noticeable tide. And so in the event that we have posted, I linked a video it's a very complicated but in-depth look at how all of those gravitational forces work to have the tidal forces. And I just love that they describe tides like a giant Earth-sized pimple. So as you if you're gonna go pop a pimple, which I think is not recommended, that's what I want you to imagine gravity's doing to our oceans, is pushing in on the oceans and causing a pimple that kind of bulges out on either side. And so as that bulge, it'll happen on equal and opposite sides. If we're in our full moon, or if the moon was over on this side in our new moon phase, we would have this bulge. I'm going to erase this just for ease of understanding here. And so that pull, as the Earth is rotating, anywhere where you're in this high bulge range, you're going to be experiencing that high tide that we mentioned earlier, and then anywhere where you're kind of in that 90 degrees off, you're going to have a low tide. And then because the Earth is rotating within this bulge, that's when you're going to experience that water shifting when you go to the beach. So kind of just a cool thing that's always happening whether we notice it or not. And of course, it changes based on where the moon is. Because if our moon's in one of the quarter phases, say up here, so we're going from new moon to, or full moon to new moon, then this bulge kind of gets distributed out. And so we have a less of, like, I guess, a more equal pull around. And there's two different ways that this is described. And I have a handy diagram to show you. We have our spring tide, which is when we have the full moon and new moon, and then we have neap tides. Now, spring is a little bit misleading because you'd think, okay, it's April. It must be the spring tide time, but that's constantly happening whenever there's a full moon or new moon. So think more like a jump. It's springing to those really extreme tidal fluctuations versus our quarter moons where it's called a neap tide, and it's kind of evenly distributing that lovely pimple push, and you have a less extreme change in those tides. And that is indeed why Harbor WildWatch cannot do a low tide beach walk any time of day, anytime we want. So we have to wait for those fuller new moons to get the really low tides. Granted, if y'all want to get some snorkel gear, we really could do a beach adventure any time of day. So, you know, it's cold here though. So with that, we kind of have an idea of how that water, let's see, is changing on our Earth. And so what we're gonna do is we are gonna make the tide-o-metric so that we can kind of play with those bulges of water and hopefully see it better than this drawing right here. So what we're gonna do is I'm gonna shift our camera angle down so that you can follow along, and we're gonna do a little bit of crafting. So the first thing I'm gonna have you do is trace a circle on either end of your piece of paper. Again, reduce, reuse during this time. The more of that, the better. And then we're just gonna cut that out. All right. Now, on one of these, you're gonna just get to choose which one's the sun and which one's the earth. I'm just gonna randomly color one yellow for the sun. And then we can get kind of fancy. We can do kind of the green blobs for our wind. Maybe some nice water on our earth. All right, now we're gonna think about those bulges again, because another thing to mention, I'm going to shift back up to this, is kind of thinking about our Earth, Sun, Moon scenario. The moon and the sun, if I were to look at them in the sky, obviously don't look directly at the sun because that's not good for your eyeballs, but they appear to be the same size, but they're very, very different sizes. The moon is about 400 times smaller than the sun. The sun is a massive ball of burning gas, right? It's huge, but because it's about 93 million miles away, it appears as if it's the same size as the moon. So it appears small because it's far away, so that perspective of ours is just a little shifted based on that. And the moon, of course, appears large, but it's also much closer. So I don't remember numbers very well, so I have it written down here. It's about 238,866 miles. And that is a little bit more, but is roughly about 400 times closer to the Earth than it is to the sun, that being the moon. And so because the moon is closer and smaller, and the sun is big and far away, they both have a little bit of influence on those gravitational pulls. So on your Earth drawing, I want you to take a blue marker and just give us a tiny bit of that bulge on either side as that, you know, the sun pimple, we could call it. So we're gonna add that in. Everybody get your sun pimples. Excellent. Oops. Cool. Okay, now from here, this part's a little bit strange. We're gonna get our moon part ready. So I'm just gonna take a nice chunk of packing tape, and as best you can, we're just gonna fold that in half. The Exploratorium, the place I got the idea from, they recommend printing off things on transparencies, and that is not things I have access to. So we're doing kind of the fun rigged model that I think I found it. I did a test run earlier and it worked out pretty nicely. So on your piece of packing tape, you also, I'm imagining, could use like a sheet protector if you just want to cut a slice of that. But tape seems to work pretty well. I'm going to have you kind of over the top of your, move that out of the way, over the top of your sun and earth part, we're going to use a permanent marker. I have a blue permanent marker or a black permanent marker if you don't have some fun colors. We're going to add another bulge that's bigger than our sun bulge. This, I guess, pimple is going to be the moon pimple. And so I want you to draw that a little bit bigger than your sun pimple. And then on the other side of your transparency, you can add a circle. Again, that Sharpie. This Sharpie's not very good. There we go. Nice circle on the other end to represent your moon. Now once you have your nice little transparency ready, this is where your push pins and cork come into play. I'm gonna just have you essentially start with the sun on the top. You're gonna stab through the middle of the sun into your cardboard box. On the opposite side, you're gonna put that piece of cork in so you don't get poked. And then we're gonna pin down our other piece here. So lay that over the top of your earth again. Stab through the middle of your earth. Again, safety cork. Boom. We officially have the Tide-O-Matic. And with this, we can now play. I'm gonna put our moon phases back up, because we can kind of go through, get everything in here, the phases of our moon, and then think about how the tides are changing based on the moon's position, because I can now, spin that all the way around. So if you move your moon to the new moon phase, you can see that we have the added bulge of water from the moon pimple and the sun pimple, kind of really increasing those extreme tides. Those again are going to be your really high tides and your low tides. And then if I shift my moon over into the quarter phases, you'll notice kind of those bulges are going to cancel each other out to some degree. Kind of get that on the screen. I don't know if you can, let me make this a little bit darker for you. Awesome. Hopefully you can see that better. And so then as you shift back into, say, a new moon phase, you then get the additive bulges, or tide pimples. Sorry, I don't know if that's really gross or like perfectly descriptive. I kind of love it and hate it at the same time. And then, yeah, you can just keep moving your moon around, and these observations of the moon that you'll notice will, again, nicely or connect to this lovely tide model that we've just created. Now, you can, of course, kind of think about models like this is not a perfect model. We don't have the distances scaled out. The sun is not 93 million miles away from the Earth, and I'm sure our sizes could be improved here, because right now the Earth is the same size as the sun. Like, there's just some things that are wrong with this model. But in general, I hope that it helps you kind of solidify that idea that as the moon is spinning, that's really shifting that water, and that is what gives us those really cool tides. And then kind of, I did want to mention the king tides, because that's a phenomenon that happens in, I guess, in Washington for sure, other places as well. But that is because our Earth is orbiting the sun in an elliptical pattern, as well as the moon is also in an elliptical. There's times where when we have either a new moon or a full moon and we're in that closest part of the ellipses to the sun, then you get like the most extreme poles of the tides are at perigee, and that is like when you get like water that here at Scansey Park, or the home of Harbor WildWatch, we get tides that can sometimes come over the bulkhead here, and so not ideal as our water levels change. Those king tides will feel them in a more extreme way. So definitely, if you end up making your own tidomatic today, we'd love to see pictures of it, maybe even videos explaining your different phases of the moon, as well as whether you're in a spring tide phase where it's really pulling either direction, or a neap tide phase where it's a little more muted. But either way, I hope you have fun with this. It's kind of a cool way to think about how the moon is impacting the water on our Earth. So I know there's some nice low tides coming up soon, so we'll be doing some live videos out on the beach, and I know we're hoping to find an octopus. So stay tuned for those, and thank you so much for joining our Science Monday today, and we'll see you next week.